All right, we're starting chapter 5 today on linear functions. So you're going to need to pause the video because, as always, I'm going to go kind of fast for those students that miss. I don't like the video to be too long. All right, so objective here, chapter 5, linear functions. We have the independent variable. It doesn't rely on another variable, but the independent variable specifically is known as the x value. The dependent variable relies on the other variable, and that is known as our y value. And then we have what's called rate of change. It shows the relationship between two variables. Now, as we go, we're also going to know the rate of change is what we call the slope. And I don't have my own home computer, so I'm writing that with a mouse. I'm not going to write it with a mouse the rest of the way here. Okay, first example says it's got a marching band, and the table shows the distance that a marching band travels over time. Is the rate of change with respect to time constant? What does the rate of change represent? So we're going to try to answer that. We're looking at a little table here, and I've got the table over here on another page. So we're going to look at this, and first we're going to find the rate of change from 1 minute to 2 minutes. So we're only going to use these values. Now, rate of change, what we're going to look at how far they traveled from 2 seconds to 2 minutes down to 1 minute. So in our rate of change, first of all, what we're going to do is we're going to take in the top, they traveled 520 feet in that second minute, and we're going to subtract because on the formula, sorry, I forgot to give you this formula, our rate of change is our change in distance over our change in time. So how much has it changed in distance over how much it has changed in time? So we're going to look at those specifically for this. You can ignore those numbers on there. For this one, we're going to look at this next one. So in this time, what did they change in distance? They changed from 520 feet in the 2 seconds and 260 feet in the 1 second. Now, the change in time was 2 minus 1. So we subtract these to find out what's the difference because the change in the distance, the change would be 260 feet. Rather than 520, they traveled 260. Rather than 2, it was 1 second. So it's 250 feet in 260 feet in 1 second. Let's see what the rate of change is from 2 minutes to 3 minutes. So from 2 to 3, we're going to use different numbers. We're going to use the 780. We're going to compare it to the 520. So if we subtract that, 780 minus 520 is 260 feet. And that's from 3 seconds to 1, or 3 seconds to 2 seconds. So that's 260 feet in 1 second. Now notice that's the same rate of change. Every second they're traveling 260 feet or 260 more feet specifically. So what's the change from 3 minutes to 4 minutes? Again, pause the video if you need to. I'd like you to try that. See if you can just compare from 3 to 4 minutes and subtract those and see what we get. See if it ends up being the same. Okay, I'm going to assume you unpause the video, and here we go. We traveled 1,040 feet by the 4th second and 780 feet by the 3rd second. So we take 4 minus 3, we get 260 feet in 1 second. So what is the rate of change? What does it represent? It represents how fast they're traveling. They're going 260 feet per 1 second. So really what it represents, let's see if I forgot to fill this one in. It represents the feet per second. In other words, their speed. Okay, that's what that represents, their speed. That last word is speed. All right, so now here we've got some pencils. Number of pencils is the rate of change constant with respect to the number of pencils bought. So we're going to look at this. Now we could check all of them. I'm going to look from the time we bought 4 pencils to 1 pencil, and I'm going to see if through the chart it's the same. So I'm going to take the cost. The cost was $1, and now you're going to get used to this, especially when we go to the next one. We always put y over x. Y is our dependent variable, x is our independent variable. I'm going to take $1 that we spent and subtract quarter. And then on the bottom where we spent $1, we always want these to line up. We're going to take 4 and subtract 1. So I get 75 cents over a change of 3 pencils. And if I divide that out, what it gets me is 0.25 per pencil, or if I put a dollar sign on there, it's costing me a quarter per pencil. Now I'm going to see if it's the same up here. So I'm going to compare when we bought 12 pencils to when we bought 7. So that's going to be, again, my bottom number. I'm always going to put Y on top. So I'm going to take 3 and subtract $1.75. And then with the 3, what goes with the 3, you always want to match this up, is 12. So in the bottom, I'm going to put 12, subtract 7. And what I get there is $1.25 over 5. And when I reduce that, it shouldn't be a surprise if I take 1.25 divided by 5, it gets me a quarter per pencil. So the rate of change is the same. It's always costing me 25 cents for a pencil. Okay, so next, it brings up this idea of the concept of slope, which is the rate of change. It's the ratio of the fraction of the vertical change, which is called the change in y, to the horizontal change, the change in x. And you may have heard this before in another class. It is the rise over the run. Okay, so vertical change rise over horizontal change run. Okay, so next, how do we know if the slope is negative or positive? Okay, here we're looking at the rise over the run. So remember, rise, what I tell students is focus in on the corners. You have to hit the corners of a graph. So I've got a couple of dots on there already. Hopefully they're clear on yours. And if I start, I always say, try to read from left to right. It really doesn't matter. We could read this backwards, but then it would be in a different way. To get from this dot here to this dot there, what I would have to do is I would have to go up 2 units. Now that would be called a positive because it rises 2. And then it goes right 3 units, so it's over 3, it's a plus 3. So that is a slope of 2 over 3, or a rise of 2 over 3. This other one, if we start on this dot, we first have to rise. So rise means goes up and down. So over here, the reason I started here is I had to go up or down to get to the same level as the other one. With this one, to get to the same level of that one, I have to go down 4. So in terms of finding the slope, that would be a negative 4, okay, over a positive 5. Okay, and that is a negative slope. Now, another way, when you look at the line, if you go up from left to right or down from left to right, you should be able to tell if it's positive or negative just by looking at it. Okay, this one, if we look at this one, the rise, to get from this point to that point, first I have to rise 2, and then I have to run 5, go over 5. This one I have to go down 2, and then over 6. And you got to make sure you can count. Now, this one doesn't count. I meant 0.0. I go over 1, 2, 3, 4, 5, 6. That's how I'm getting the 6. It moved right 6. I see 7 dots there because the first one counts as dot 0, and then we go from there. And that gets me negative 1 over 3. Okay, so that ends the first lesson on this.